Let's start with this question. So we're given an equation. It's a rational function, right? Because you have a linear on the top and a linear on the bottom. And t's time and the y value there, c of t. That is your concentration of whatever this is, salt. Now the question is, when is the concentration, or when is the y value 3.75? So it looks difficult, but I don't think it's too bad. It's because this is not even a quadratic, so it's probably like a 3-step answer. You want to be able to solve this equation for t. We're looking for the time when the y value is 3.75. All right, how do we solve this equation for t? What do we do first?
You multiply both sides by 25 plus t.
Yeah, that's gonna work. So 3.75 times 25 is 93.75. And then you have 3.75 times t, which is 3.75 t. On the other side, you have 10 t. Now, this is a very simple linear equation. What do you do next? You want to group up the like terms. Okay, there's a t here. There's a t here. You're going to move this guy to this side. Subtract 3.75 t on both sides. Because then we'd have t's on both sides, and that's always the goal. If you have unknowns on both sides of the equation, make sure they're on the same side so we can group up the like terms. Next, you're gonna divide both sides by 6.25. And the answer is 15 minutes, because t's in minutes. So after 15 minutes, the y value of this rational function will be 3.75, okay? Easy enough? We can also graph this. You want to tell me, does this have an oblique asymptote or a horizontal asymptote? Look at the degrees on the top and the bottom. Oblique is when the degree in the top is bigger than the denominator.
It's not oblique.
No, it's not oblique. So what's our horizontal asymptote here? To find the horizontal asymptote, you take the ratio of the leading coefficients on the top and the bottom. What's the leading coefficient of the t on the top?
10.
10, right? What about the bottom?
25.
No, that's not a leading coefficient. The leading coefficient is 1. Leading coefficient is whatever's multiplied to the variable. So your horizontal asymptote is going to be at y equals 10 over 1, the leading coefficient of the numerator over the denominator. 10 over 1 is 10, so the leading coefficients, the horizontal asymptote will be at 10. Where's the vertical asymptote? To find the vertical asymptote, you set the denominator equal to 0.
It's negative 25.
Yeah, it's negative 25. So we have these two. 2, 3, 4, 5. Let's make that 10, and negative 25 is down here. So you have this asymptote, and then you have it at 10 as well, like this. Let's find the x and the y-intercept. To find the x-intercept, you set the y equal to 0. So you get something like this. How do you solve this for t?
You multiply by 25 plus t.
Does it disappear when you multiply?
It does.
It does, yeah. So 10t is equal to 0. T is going to be 0. So we know our thing is going to pass through the origin. Okay, there. And then I'm going to quickly check for a point beyond this. I'm pretty sure this is going to end up looking like this. And then usually that means you have something up there. But sometimes it's tricky. Sometimes you could have something down here. But yeah, we don't even need to check. Like, think about it this way. If we had something down here, would we have another x-intercept?
Mm-hmm.
We would, right? If we had something down here, we would have another x-intercept. But we don't. We only have one x-intercept of t equals 10. That means there's no way our thing is going this way. It must be up there. And that's the only two possibilities when you want to write the asymptote. But you can double check that, right? So if I want to check where am I, above the asymptote or below the asymptote here, I have to pick a number that's less than negative 25. So I can pick negative 26. So this becomes negative 260 divided by negative 1. It becomes positive 260. So at negative 26, I'm all the way up at positive 260. Okay? So I must be up here, not down here. And if I was down there, we would get another x-intercept. So that's another way to see this. Why is this relevant? The question was, what's the x value when the y value is 3.75? 2, 4, 3.75 is somewhere here, close to 4. Then you go this way. Then you go down this way, right? It's almost 15, but we know the answer is exactly 15. But on this curve, if I had more points, it probably would have been more precise. But there you go. That's the answer that we're looking for. When the y value is 3.75, the x value is 15 minutes. And we are done with that question. So this person bought some t-shirts for $4.50. She kept 2 of them and sold the rest for $5.60, making a profit of $10 on each shirt. How many t-shirts were there in the case? Pretty tricky question. What should our x be?
The amount of t-shirts.
Yeah. So x is the number of t-shirts that she had. Okay, let's say this is her cost. So it cost her $450, right?
Mm-hmm.
To purchase X t-shirts. So in terms of X, what's the price of each t-shirt? Right? If you have 20 things, if you spend $20, you bought 10 items, you just divide them. The price will be 2. Same idea, right?
Mm-hmm.
Price is going to be cost over quantity. The second part is going to be slightly tricky, I think. She kept 2 t-shirts to herself. So how many t-shirts is she actually going to sell in terms of X?
X minus 2.
X minus 2. What's the revenue? How much did she make? This number,
560.
560. What's the price per t-shirt for the revenue? Just divide them, yeah? Price is always
X
going to
minus
be
2 over 560.
the other way around. Money over quantity will be price. So we have our cost data, we have our revenue data. Remember, profit is going to be revenue minus cost. Whatever you earn minus whatever you spend. That's going to be your profit. What's our profit per t-shirt? It's 10, yeah? It says up there, the profit is 10 on each t-shirt. So you just use this equation here. The profit for each t-shirt is going to be equals to the revenue for each t-shirt minus the cost for each t-shirt. So this becomes 10, the profit for each shirt, and then the revenue for each was 560 minus x over x minus 2. The cost was 450 divided by x. There we go. That's our equation. Did that make sense?
Mhm.
So you need to know that price is going to be cost over quantity. It's common sense as well. Like if you just use a simple example, I bought $30 worth of candies. I bought 15 of them. What's the price? It's going to be 2. It's always going to be price over the quantity. Now here's our rational equation. How do we solve this for x? It has a fraction, so that's a hint.
You find the common denominator.
What is common denominator here?
You can multiply the two.
Yeah. So it will be, I need to multiply 560 by x, right? What do you need to multiply 450 by? It'll be x minus 2. Okay, like that. We're taking the common denominator. Basically, this one's missing an x. This one is missing an x minus 2, right? Like that.
Mm-hmm.
And the entire common denominator is x times x minus 2. So you have 10 equals 560x. I'm going to open that bracket. I get this. Does that help us? So this will be 90x plus 900. So 10 is equals to, not 90, sorry, it'll be 110. 110x plus 900 all over x squared minus 2x. How do we solve this for x?
You multiply x squared minus 2x.
Yeah, I think that's gonna work. And we don't really need all this because we're trying to find x. So if we get x, we're good. So then this becomes, what does it become? It becomes 10x squared minus 20x is equals to 110x plus 900. Now let's move everything to the same side. It'll be 10x squared minus 130x plus 900 equals 0. If you can pull something out, always pull something out. It'll make your life super easy. That 10 disappears. Now we have to man this. Two numbers that multiply, I don't know if it's possible, but multiplies to 90 and adds to negative 13. Any ideas? One of them is 5. It's 18 and 5, in fact. It'll be negative 18. Positive 5, does that do it? Yeah, there's a mistake here. That does do it, but I didn't put a minus sign on the 900. So this should have been 90. Negative 18 and negative 5 will do it, right? Positive 5. Yeah. Adds up to negative 13, multiplies to 90. There you go. So your answer is 18 and your answer is negative 5. Does the number of shirts being negative 5 make any sense?
No.
No, it does not. So there were 18 shirts in the pile. Okay?
Okay.
So what does that mean? That means she bought each shirt, there were 18, so her cost was 25. So that means she kept 16 shirts and sold the rest for 560. That means she sold it for 560 divided by 16, which is $35. And look at the profit. She sold it for 35. She bought it for 25. It's $10. So the math checks out. Okay.
Mm-hmm.
Pretty tricky question, this one. A lot of ideas, and yeah, if you don't identify it as a rational function, then you're pretty much toast. It's always tricky. These questions are the trickiest, I find. All right, so we need that equation to be true. They have given us the length, and we must figure out the width. Okay?
Mm-hmm.
What's our approach here? They've given us the length, we just need to find the width, right? So let's write the equation. So length is 15, width is width, width is width, length is 15. There we go. We have one equation, one unknown. What's our next step?
Do you like cross multiply?
Yeah. What's 15 squared?
225.
So 225 minus 15w is equals to w squared, okay? Move everything to the same side. I always like my a value to be positive, so I'm gonna move these two. Is this solvable? 225. 25 and 9. But that does not, that adds up to 16, not 15. Can't really think of anything else that multiplies to 20. It's either 15, 15, 25, 9. Yeah, no idea. So what do we do here? We're not gonna waste much time on these. If you can figure out the man, you figure them out. Here the A value is 1, here the B value is 15, here the C value is minus 225. Remember the quadratic formula?
Mm-hmm.
What is it? That's a hard question. It's this. It's negative b plus minus b squared minus 4ac over 2a. Very useful. There is an x-intercept here. We know that because it's opening upwards and the y-intercept is negative 225. So we're going to get two x-intercepts. One of them will be positive and one of them will be negative. Right, there we go. That's what we have. I'm going to plug that in a calculator. -15 plus. The plus will give you a positive, usually, divided by 2. One answer is 9.27. Now the other one I'm going to do minus. So -15 minus square root of 15 squared minus 4 times 1 times -225 divided by 2. Which gives me -24. Does -24 being the width of a rectangle make any sense?
No.
No, so our width must be 9.27, okay?
Okay.
Let's see what that ratio actually gives me, because this is kind of interesting. So we had 15 over 9.27 on this side. What is that ratio? It's like 1.62. Not sure what's the importance of that is. I'm trying to see what a golden rectangle is. That is the ratio right there that we just found, but I guess the shape gives you this spiral pattern, which is kind of good to look at, right? Look at these. Yeah, it's not super important for this question, but yeah, this question wasn't too bad either. Which means if you get a decimal number for your x-intercept or your solution, probably means this thing is, you can't man this. Which is why it's important to know the quadratic formula. And now we have a working together problem. Just remember to flip it. You do it in 1 minute, and then you flip it. You do 1 minute individually, you add up the 1 minute individuallys, and then you flip it, and that'll give you the total time. All right, so machine A takes S minutes. Machine B takes S plus 10 minutes. So in 1 minute, what fraction of the task can machine A do? If it takes
1 over S.
Yeah, 1 over S. The other one will be 1 over S plus 10. Now combined in 1 minute, machine A and B together, we will do 1 over S plus 1 over S plus 10. Take the common denominator. So multiply this by S, multiply that by S plus 10. You will get something like this. So you get 2S plus 10 over S squared plus 10S. This is the task, the proportion of the task they can do in 1 minute, okay? That is combined 1 minute. How do we get the time it takes for them to finish the task if we have the combined 1 minute?
You flip it.
You flip it, right? So we do S squared plus 10S all over 2S plus 10, and they have given us the time it takes for them to finish the job. It's 15. Multiply both sides by the denominator. You'll get 30S plus 150. Move 30S to one side. You'll get S squared minus 20S plus 150, right? Multiplies to positive 150. 10 and 15 doesn't work. Yeah, I don't know. I think they just want us to use the quadratic formula for most of these. 30 and 5 doesn't work. 25 and 6 doesn't work. I can't really think of anything that works, but that's fine because we have a quadratic formula. Look at this. It's negative b, so this negative 20 becomes positive 20, okay? Plus minus b squared, so that negative being doesn't have any impact because you're squaring anyways. So you can either write -20 squared or you can just write 20 squared. Because we're squaring them, so that has no impact. So there you go, that's the quadratic formula. So probably one of them will be negative. Nope, this doesn't work because I again didn't put a negative sign here. This should have been -150. Now it should work. So that's 4 times, because when I moved this, I didn't put the negative sign. So let's try that again. 20 plus 20 squared minus 4 times -150 divided by 2. So the answer is 25.8 minutes for one of them. And then we can do the same thing with a minus sign to see if we have another solution. And we'll see if that solution makes sense. No, it does not, because I got a negative time, -5 minutes, not possible. Therefore, S is 25.8, which is the time for machine A. That means machine B takes 35.8 minutes. So this is another unmannable question, or if you can man it, it's not very obvious. So yeah, just use the quadratic formula. Once you do this a few times, you'll be used to this. It's not terrible. But yeah, this is the combined 1 minute thing question. Just flip it and you're done. Straight up a flip question. Let's do another flip question, but I think it's gonna be trickier. Oh, it's gonna be trickier because now there's 3 people. So far we've only done it with 2 people. Does that change anything? Changes absolutely nothing. You get combined 1 minute, you flip it. So we have 3 people. Tom can finish it in S minute. That means in 1 minute, what fraction can Tom fill? It'll be
1/s.
1/s, right? The other person is S minus 2. That means he's going to finish 1/s minus 2. The last guy is S plus 10. That means it's going to be 1/s. Oh no, this is going to be awful to take the common denominator. But let's read the question. It says, when Tom and Paco work together, they take 1 minute and 20 seconds. Okay, so we need the combined time of T and P, right?
Mhm.
So we need the combined time for this guy and this guy. So that'll be 1/s plus 1/s minus 2. This is for 1 minute. That'll be s minus 2 plus s/s squared minus 2s. That'll be 2s minus 2 over s squared minus 2s. So this is the time Tom and Paco in 1 minute. This is the fraction of the job in 1 minute. So how long does it take them to finish the job?
You flip it.
You flip it, right? So that means s squared minus 2s. And remember, s is in minutes. 2s minus 2. What is 1 minute 20 seconds in minutes? So we have minutes and seconds, but we don't want seconds. We want it to be minutes because s is in minutes. Ideas. The question is, what is 1 minute and 20 seconds in terms of minutes? And let me give you a hint. It's going to be a fraction. 30 minutes is 1/2 hours, right?
Mhm.
What's 20 seconds in terms of minutes? It's going to be a fraction. You want a hint? 10 seconds is 1/6.
It's 1/3.
It's 1/3, perfect. So 20 seconds is 1 over 3 minutes. So 1 minute and 20 seconds becomes 1 plus 1/3, right? 1 minute plus a third of a minute, which is what, 4/3, I think, yeah. So there you go. This is what we have. We've already flipped this. Now let's cross multiply. So this becomes 3s squared minus 2s is equals to 8s minus 8. Move everything to this side. So this becomes 3s squared minus 2s minus 8s is minus 10s. And that 8 is positive. This one's actually pretty simple. It multiplies to 24. Is it? Keep overstepping. Multiplies to 24. Yeah, this is possible. And adds to -10. What are the numbers? Multiplies to 24, adds to -10.
6 and 4.
Yes.
-6 and -4.
-6, -4 does it. So this one we're gonna actually do it like this. So 6s, 4s plus 8 equals 0. From the first two terms here, you can pull out a 3s. You're left with s minus 2. From the next two terms, you can also pull out an s minus 2. So this becomes 3s minus 4 over s minus 2 equals 0. So s is 4/3 and s is 2. Okay? Does that make sense though? Four over 3 is 1.33 minutes, right? 1.33 is out because if you do s minus 2, that'll give you a negative number. But something go wrong here because Paco can do it instantly according to this logic. Let's double check. S and s minus 2, s and s minus 2, 1 over s minus 2. That's 2 plus s, 2s minus 2. We're good here. 3s squared. Okay, I figured it out. There's a mistake right here. 3 times 2 should be 6. What gave it away was this, right? Look at this. If s is 2, s cannot be 4/3. If s is 2, yeah? Look up here. Paco can finish it in s minus 2. So he's like, I don't know, like a higher being or something. He can finish it instantly in like 0 minutes, which is not really practical, is it? Can he finish a job in 0 minutes? No. That's why I knew something was wrong. And I know what it is. There was an issue here with this. So this is supposed to be 14, which probably means our two numbers are -12 and -2. Okay, there we go. What does that change? So that'll be s minus 4 here. And you take out a 2. And that'll be s minus 4. All right, we have it. So it should be 3s minus 2 and s minus 4. So our two timings are 2 over 3 minutes, which again doesn't make sense because you'll get a negative number for Paco. But s being 4 makes sense now because Paco's time will no longer be 0 minutes. Cool? So s is 4. So that means this guy takes 4 minutes. This guy takes 2 minutes. This guy takes 4 plus 1, 5 minutes. That's the answer to part A. Part B, how long would it take all three of them working together to fill the order? Now what? What's the approach now? What's the first step? Now that we know how long it takes them, not in terms of x, but we know exactly how long it takes them in terms of 4, 5, and 2. Any ideas? We have the time it takes for all of them individually. It's 4, 2, and 5. The question is, how long does it take if they work together? How long does it take them?
You put the numbers under 1 and then you add them.
Yeah, exactly. You put the numbers under 1, you add them. That'll give us the combined 1 minute, right? And then you
And
flip
you
it.
flip it.
That's it. That's it. And here it's we're just adding fractions, so it's even easier. 1/4 plus 1/5 plus 1/2, right? The common denominator is 20. So multiply that by a 5, the middle guy by a 4, the last guy by a 10. So you get 19/20. And then you flip it upside down, which means it takes them 20/19 minutes if all three of them work together, okay?
Mm-hmm.
And that's the end of the question. We are done. Here's another question that says A's for application. So polluted water flows into a pond. We're given the concentration and we are given the time in minutes. Part A says, when will the concentration be 6? What's our game plan here? We want to find the time when the concentration is 6. That's it. Replace the y with 6. Then you get something like this. But this one could be tricky to solve. Not really though, now that I look at it, it's just a linear function on the bottom. There you go, that's our equation to solve. What's the first step? Any ideas? We're trying to solve for the t. It's at the bottom right now, but here's what you do. First get rid of this 9, okay? How do we get rid of that 9? We're gonna throw it to the other side.
You subtract.
You subtract. 6 minus 9 is -3. Then you get rid of this -90,000. What do you do on both sides?
You add.
Adding won't help. Try again. Because -90,000 is being multiplied with this
Oh,
bracket.
you divide.
You divide, yeah. So -3 over -90,000 is gonna be 1 over 30,000. Then you have this. Now what?
You multiply by 10,000 plus 3t.
Yeah, you can just cross multiply on both sides. So that'll give you 10,000 plus 3t on here, right? Multiply here, and then it'll give you 30,000 on the other side. Then you subtract 10,000 and divide by 3, and you're done. So 20,000 over 3, which is what? 6 6.67, I think. It's 20,000 divided by 3. And that's the answer. Okay?
Mhm.
So after this amount of time, the concentration will be 6 kilograms per meter cubed. Part B is more trickier though. It says what will happen to the concentration over time. How do we answer that? We basically need to sketch this, which is going to prove more difficult than it needs to be. All right, how do you go about sketching this? Let's take the common denominator. I want to see what the horizontal asymptote is. Usually that's the answer. Once you find the horizontal asymptote, that's what's happening to the concentration. So you get, I'm just taking the common denominator. I'm multiplying that 9 by 10,000 plus 3t. So we have 90,000 plus 27t minus 90,000, okay?
Mhm.
All over 10,000 plus 3t. This and this cancels out. So we have 27t over 10,000 plus 3t. Where's our vertical asymptote? Vertical asymptote is when the denominator is set to 0.
So it's negative 10,000 divided by
3, or yes, you're right. So that's going to be negative 333 point something. But that's irrelevant because time is t and the vertical asymptote is negative. Time cannot be negative. So we're strictly kind of concerned with quadrant 1. Our vertical asymptote is somewhere down there, but we don't really care about that. Where's our horizontal asymptote?
Is that when you find the ratio?
Mm-hmm.
It's 9.
It's 9. That's the most important part. So 9. Where's our x-intercept? So to find the x-intercept, this denominator is always going to disappear. You said 27t equal to 0. Your x-intercept is at 0. The x-intercept is 0, y-intercept is automatically 0. So we know there is an asymptote there, but we know we're going to pass through this, yeah?
Mhm.
If you curve it, we don't really care about quadrant 2, but this is what the curve would look like. And remember, this value is 9. Initially, the concentration was 0, yeah?
Mhm.
What's happening to the concentration over time? How'd you
It's
describe this?
increasing.
It's increasing. It's headed towards where? What's the y value that it's headed towards? 9,
9.
right? Is it ever going to approach 9?
No.
No. So to answer part B, the concentration will increase towards 9 kilograms per meter cubed, yeah?
Mhm.
But it'll never actually hit it. So you can just say it approaches towards 9. Okay, it approaches to 9 kilograms per meter cubed. If you really want to be fancy, you can say it's increasing at a decreasing rate, because if you draw the tangents, they're all positive, but the tangent up here is more horizontal than over here. So the rate at which it's increasing, it's getting smaller and smaller and smaller, okay?
Mhm.
And that's the answer to this question. What is going on here? So we have quadratics, right? Can we factor any one of them? Can we man? By factor, I mean, can we man them? Because we don't want to be dealing with x to the power of 4s if we don't have to. Look at the top there. X squared minus 6x plus 5. We're looking for two numbers that multiplies to 5 and adds to negative 6. What are the numbers?
-5 and -1.
Yeah. -5 and -1 over there. On the bottom here, we have x minus 3 and x plus 1 does it, yeah. On the top, we have 2 minus 3x. What about this guy? Is that guy factorable? It is not, right? The only thing that multiplies to 3 is 1 and 3. And they will never add up to 3. They will either add up to 4 or 2, so, or subtract to 2. So you can't really do much with that. And now what? This question is actually really tricky because nothing canceled out. Absolutely nothing canceled out. What does that mean for us? Well, it means you have to cross multiply it. It's going to show you how to do this really quickly without spending much time because cross multiplying this is not going to be very fun because you get x to the power of 4. That's why. There's going to be 9 terms. I don't know if we should even do this. You're multiplying 3 terms with 3 terms, yeah?
Mhm.
You end up getting 9 terms, which is not very easy to deal with. But I'll just show you that it is possible to solve a question like this. It's just annoying. So what did I do? I did 6x cubed, 18x, plus, that should be minus 18x. Then for the 5, it'll be 5x squared plus 15x plus 15. So that's just this times this. And now we gotta do this times that. So that'll be 2x squared minus 4x. Or maybe I should just do it with the x squared first. So x squared times 2x squared. X squared times 3x squared. Negative 4x, positive 6x, minus 6 and plus 9x. All right, there we go. That is what we have, okay? And then you want to group everything to the same sides. There's only one x power 4, but we do have 3x cubed, 6x cubed. How many x cubes do we have? This should have been a cubed. Let me just double check. X squared minus 3x cubed, negative 4x plus 6x squared, negative 6 plus 9x. All right, so we have these three for x cubes. So that'll be negative 9 plus 3, that's negative 6x cubed, so that's done. Now we gotta worry about the x squares. 3 minus 18, negative 15, plus 5, negative 10, minus 6, negative 16, minus 2, negative 18. All right, that's what we have. Then finally for the x's, we have -3 from these two. -3 plus 4 is x, minus 9 is -8x. And then finally we have the 6. When we throw it to the other side, it becomes +6. There we go. That is what we have, okay?
Mhm.
You remember how to factor things that are greater than degree 2?
Mm.
What you do is you use the remainder theorem. We're not going to get into it right now because we don't have enough time, but you want to look for factors of 6 that would make this equation true. For example, if you plug x as 1, this equation is not going to be true. Then you check it with 2, see if that equation is true with 2. Then you check it with 3 and such. But here we're going to do a quick check. So the answer to this question, there's 2 x-intercepts. One of them is here and one of them is here. And this you can figure it out by doing polynomial long division after using the factor theorem. Okay? It's a very tricky question, but it is doable. I was hoping things would cancel out, but it does not cancel out. So sometimes that's just how it is. You have to go old school. Let's look at this thing. ST is their position, T is their time. Question A, when are the objects at the same position? So we're looking for time when the y values are the same. So what do we do here? We want to see when their y values are the same. That's the goal. You just set the y values equal to each other, right? And hopefully we get something that we can solve. These questions are going to be a little bit more trickier than the linear type we've been doing. But it shouldn't be that bad. Like this one, we just leave it as it is. The other part, we take the common denominator. That's the only thing we can do. Then you get something like this, okay? And then you cross multiply. Isn't that always fun? So you get 7t squared plus 14t. On the other side, you'll get t4 plus 2t cubed plus 5t squared plus t squared plus 2t plus 5. Then again, you move everything to the same side. You'll get a power 4 polynomial. So 6 minus 7 is -t squared. -12t plus 5 equals 0, like that, okay? Now again, we have a degree 4 polynomial. You see that? Degree 4? Anytime you have a polynomial with degree 2 or up, you have to use the quadratic, not the quadratic, sorry, something called the factor theorem. Maybe we'll get into it next time. We have done it once upon a time. What you do is you check for factors of 5, which is only 1 and 5, and you plug it in here and see which one of them makes this equation true. After finding that, you find the polynomial, you do polynomial long division, and that will give us t as whatever it is. So at that time, the distances, their positions are going to be equal, okay? That makes sense?
Yes.
Once you find the t value. So this is just cross multiplication, except we're dealing with higher degree polynomials. B is a more interesting question. When is object A closer to the origin than object B? What does that mean? What do you think that means? We can graph it, right? We can graph it, but basically the idea is when is that thing closer to the origin? Means, yeah, just closer to the origin in terms of its distance compared to the other curve. Okay,
Mm-hmm.
here I've graphed them. This we could have done by hand as well, because there's an oblique asymptote somewhere for one of them, and somewhere there's vertical asymptotes. Is the red one closer to the origin, or is the blue one closer to the origin? What do you think? Origin is here. Which line is closer, the red one or the blue one?
The red one.
Yeah, the red one's definitely closer. It's closer up until a certain point though, right? Because if you look at this distance is 2.5, yeah? From the blue
Mm-hmm.
to the origin. Whereas for the other guy, you get like a little triangle. See this? So the answer to this
Mm-hmm.
one is the red one is closer, okay? Up until when the hypotenuse is less than 2.5. Because if the hypotenuse is greater than 2.5, then this would end up winning. The blue would be closer, okay? So that's
Mm-hmm.
how you'd approach that question. All right, we can call it a day there for today.
Okay, thank you.
See ya.